So this is an introduction into organic molecules, and if you remember from chemistry, an organic molecule is any molecule that contains carbon atoms. That's the criteria that it has to meet in order to be considered organic. So that obviously includes a whole lot of molecules. We're going to start talking about hydrocarbons. Hydrocarbons are the simplest organic compounds because they contain only carbon and hydrogen. The picture you see here is methane, okay, and methane is 4 single bonds between a carbon and 4 hydrogens. Oops, let's go back to that. Um, you can obviously have any combination of carbons and hydrogens. There could be, we can get really, really long chains that include hundreds of carbons, but this is one of the most simple, excuse me, with its 4 single bonds. Carbon has 4 valence electrons, so it easily forms those 4 single bonds with the hydrogen. Now, when we're talking about within the group of hydrocarbons, the simplest form of hydrocarbon is what we call the alkanes. The alkanes are hydrocarbons in which there's only single bonds. So if you look at this picture here, you'll see that there's single bonds between the carbons and there's single bonds between the hydrogens. Okay, if I had a longer chain with more carbons, it would just be single bonded carbons attached to each other. Okay, that would be an alkane. And then all the hydrogens are also single bonded to the carbons. And this is what we would call a saturated molecule. You've heard of saturated fats, I'm sure. Saturated molecules mean that it's all single bonded. So we're putting the most amount of hydrogens on this molecule as we possibly can. We're not taking up any of carbon's valence electrons in a double bond. We're not occupying them that way, but we're using single bonds only throughout this molecule. And the name of the molecules are going to end in ane because they're alkanes. Okay, that ane indicates single bonds between all of the carbons. So whenever you see a molecule like ethane, butane, those have only single bonds between the carbon. Okay, this one here happens to be ethane. Excuse me. 2 carbons is the eth prefix. So ethane for the single bonded 2 carbon saturated molecule. Here is a chart to sort of give you an idea. You're gonna need to know these eventually, the prefixes for the different carbons, but it sort of shows you what the structure is going to look like. Here was the methane with the single carbon and the 4 hydrogens. Ethane with its 2 carbons. Each carbon had 3 hydrogens attached to it. If I go back to that previous slide so you can kind of see that, the structural formula is basically giving it in chunks. So it's CH3, CH3. So you're kind of seeing how it's structurally put together as well. Okay, if you move down here, propane is 3 carbons. So you'll have the carbon on the end with its 3 hydrogens, this carbon on the end with its 3 hydrogens, and then in the middle, bonded on both sides to another carbon is this one, and then the other 2 valence electrons have hydrogens on it. So you'll notice as we go down that the middle ones only have 2 hydrogens. And that's because they're bonded on both sides to a carbon, taking up 2 of their valence electrons. And it goes on like this all the way down. So you have methane, ethane, propane, butane is 4 carbons, pentane is 5 carbons. This is sort of where it starts making a little more sense numerically. Hexane is 6, heptane is 7, octane is 8, nonane is 9, and decane is 10. We will occasionally deal with ones longer than 10, but for right now, those are the names I'd like you to be familiar with. So let's look at the molecular structure or the molecular formula versus the structural formula. Because what you saw on the last slide was the structural formula right here with the CH3, CH2, CH3. That's showing you structurally how it's put together with the number of atoms. But the molecular formula is really the simplest and probably what you've been familiar with up to this point, which just basically gives the number of each type of atom. So you have 3 carbons and 8 hydrogens in this particular molecule. But if you look at structurally, it's showing you that it's put together sort of like in 3 segments. These hydrogens are attached to this carbon, these hydrogens are attached to this carbon, and these hydrogens are attached to this carbon. Another way of doing that is to just put the dashes in between it to show that there's single bonds in between those carbons. And this is propane that you're looking at. So it's 3 carbons with its 8 hydrogens, and that is what the molecule would look like drawn out with all the single bonds. There are other ways of representing these molecules, which you're going to see over the course of the chapter, so let's take a look at this. If we take a look at butane, for example, we have the molecular formula. Okay, it's just simply showing you the number of atoms of each type in the molecule. You have the structural formula, which is showing you the carbons with the hydrogens that are attached. Okay, butane is a 4-carbon chain, so the middle ones only have 2 because they're attached to carbons on either side. There it is again structurally, but with those bonds in there. I don't know if that makes it easier. You're welcome to do it either way. This way is a little bit more condensed. You'll notice as the chains get longer, on the ends, because there's only one single bond to another carbon, it's able to attach 3 hydrogens. But in the middle, it's only able to attach 2 hydrogens because the carbon's bonded on both sides to another carbon. So basically, it's always going to look like one of these 2. So when we do this condensed version, we're basically just saying how many sections in the middle do we have, and that's what this little subscript represents. And then we have our 3 hydrogen sections on the end. There's a very simplified, what we call the skeletal version, in which we're just showing the carbons and we're making the assumption that all of the other attached molecules are hydrogen. So all of those other carbon bonds that are available are hydrogen. And then the last one is this skeletal form. It's basically just a line drawing, and you assume that there's a carbon at the end of each line segment. So we would say there's 1 carbon here, 1 carbon here, 1 carbon here, and 1 carbon here. Okay, and that would be just a line drawing for butane.